Hi, this is David Quatella with Siemens, and in this video we'll be covering the Siemens Quick Step Basics of Meter Mounting Equipment. This course covers basic meter mounting equipment concepts for residential and commercial applications and provides an overview of Siemens meter mounting equipment. You should have a basic understanding of electrical concepts to fully benefit from this course. And here is just a slide of some of the legal trademarks we need to cover. Upon completion of this course, you should be able to do the following. Identify the most common power supply systems used in residential and commercial applications. List and describe the main components of a single position socket. Describe the advantage of a sidewire meter socket design for an underground feed application. Explain why a bypass is sometimes needed and list the types of bypasses available. Describe the important characteristics of Siemens residential and commercial meter sockets. Describe the configurations available for Siemens gang meter sockets. Explain the difference between a transformer rated meter socket and K-based meter socket. Explain the difference between a meter main and meter load center combo. Explain what USERC means. Explain the difference between overcurrent protection devices, continuous current rating, and its interrupting rating. Explain the difference between the full rating method and series rating method. Describe the key differences between the standard Unipack metering design and Siemens exclusive ringless Unipack metering with Libre bypass. Describe Siemens PowerMod modular metering installation, and list and describe the types of modules available for the Siemens PowerMod Quick System. This course has 4 sections plus a final exam. After each section, there will be a knowledge check of approximately 4 to 5 questions. The first part of the course is an introduction that covers basic meter mounting equipment concepts. The second part covers meter sockets, third meter combos, the Siemens brand, and the fourth part covers Siemens multifamily metering. Power generated at a power plant and stepped up to a high transmission voltage is brought to a local substation. Here, it's stepped down to a lower distribution voltage. When the power reaches its final destination as a residential customer, the voltage is stepped down to 240 volts. Only single-phase power is used in a typical residential application. The most common supply system used in U.S. residential applications today is a single-phase 3-wire supply system. In this system, the voltage between either hot wire and neutral is 120 volts, and the voltage between the 2 hot wires is 240 volts. The 120 volt supply is used for general purpose receptacles and lighting. The 240 volt supply is used for heating, cooling, cooking, and other high demand loads. When single-phase power is needed for most residential applications, 3-phase power is used in many other applications. In a 3-phase system, the generator produces 3 voltages. Each voltage phase rises and falls at the same frequency, 60 Hz in the US, 50 Hz in many other countries. However, the phases are offset from each other by 120 degrees. Transformers used with 3-phase power require 3 interconnected coils in both the primary and the secondary. These transformers can be connected in either a Y or delta configuration. The type of transformer and the actual voltage depend on the requirements of the power company and the needs of the customer. The accompanying illustration shows the secondary of a Y-connected transformer and the secondary of a delta-connected transformer. These are only examples of possible distribution configurations. The specific voltages and configurations vary widely depending upon the application requirements. Power purchased from a utility company enters the house through a metering device and connects to a load center. This is the service entrance. Service can come from an overhead utility transformer or from a lateral service run underground. Most of us are familiar with the watt-hour meter located outside our homes. The watt-hour meter is typically provided by the power company and is used to determine how much electricity has been consumed for billing purposes. Watt-hour meters used in most residential applications are designed for use with single-phase power, but meters used in many commercial applications are often designed for use with 3-phase power. Residential applications often use a watt-hour meter designed as self-contained. A self-contained meter are directly connected to the power source and the load. Watt-hour meters designated as the transformer rated, or TR, use current transformers, CTs, and voltage transformers, also called potential transformers or PTs. These reduce the energy applied to the meter. TR meters are common in commercial applications because of the higher load current required for these applications. Each watt-hour meter requires a meter socket to safely and securely connect to the electrical service. Because meter designs and utility requirements vary, Siemens offers a variety of single-position and multi-position meter sockets. Single-position meter sockets are used for single-family homes and in some commercial applications. Multiple-position meter sockets, also called gang sockets, are used in multifamily and other commercial applications requiring 2 to 6 meters. Requirements for meter sockets with maximum voltage ratings of 600 volts or less and continuous current ratings of 320 amps or less per socket are covered by American National Standards Institute, the ANSI, Standard C12.7, and UL Standard 414. From the watt-hour meter, the incoming power then goes to a load center, which provides circuit control and overcurrent protection. The power is distributed from the load center to various branch circuits for lighting, appliances, and electrical outlets. Most commonly, the load center enclosure is separate from the meter socket. In some cases, however, circuit breakers are housed in the same enclosure as the meter socket. This type of product is referred to as a meter combo. When only a main circuit breaker is included, the device is called a meter main. If branch circuit breakers are also included, the device is called a meter load center combination. Unipack meter centers are an option for multifamily dwellings. These are self-contained systems with 2 to 6 meter compartments. Individual branch circuit breakers for each tenant are located in a separate compartment adjacent to each meter socket. PowerMod with Quick System Modular Metering is used for multifamily dwellings or other commercial applications where more than 6 meters are required. As the name indicates, PowerMod incorporates modules that can be quickly combined to meet varied application requirements. Basic modules include circuit breaker mains, fusible switch mains, top boxes, and residential and commercial meter stacks. A basic meter socket has 5 components: the enclosure, lugs, neutral connections, jaws, and insulating blocks. However, the other components are often added to meet application requirements. The enclosure is simply the box and cover, which are made of galvanized steel or aluminum. Steel enclosures are painted, but aluminum enclosures may be painted or unpainted. The enclosure protects internal components and limits access to the meter and live circuit elements. All Siemens meter sockets have a NEMA Type 3R enclosure. The lugs connect the wires to the meter socket. Lugs may be factory or field installed and are available with single or multiple ports. Multiple port lugs allow for the use of multiple wires. Lay-in lugs are also available. Lay-in lugs are fixed and may not be changed in the field to accept other wire sizes or parallel conductors. Stud terminals accept either lugs or compression fittings. Common uses for the studs include applications where the field wiring may be either single or parallel. Terminals may be mixed on the side or on the line and load sides. For example, a socket can have studs on the line side and lay-in lugs on the load side. All sockets include a neutral connection. The neutral conductor serves as a current return path. The neutral conductor is connected to ground at the service entrance. This is accomplished in a meter socket by connecting the service ground and neutral conductors to the same point in the meter socket enclosure. A bonding screw at this connection point secures the ground to the interior of the meter socket enclosure. Keep in mind that neutral conductors are not connected to ground at any point downstream from the service entrance. There are 3 types of meter socket neutral connection configurations. 2 connection neutrals, also called double or duplex neutrals, have 1 connection for the incoming conductor and 1 connection for the outgoing conductor. 3 connection neutrals, called triplex neutrals, have 1 incoming and 1 outgoing connection for neutral conductors and 1 connection for ground. 4 connection neutrals, also called quad neutrals, have 1 incoming and 1 outgoing connection for neutral conductors and 1 incoming and 1 outgoing connection for ground conductors. Jaws are connections that accept the blades of the utility meter and establish secure electrical connections between the meter and the meter socket. The number of jaws is directly related to the number of phases. Some jaws have springs to increase the amount of pressure on the meter blades. A 4-jaw socket is designed for a single-phase application and has one line side and one load side connection for each of the 2 hot wires. After the line, load, neutral, and ground connectors are installed, the meter can be plugged in. A watt-hour meter has 4 blades that plug into the jaws of the meter socket. Once installed, the meter completes the circuit by providing a path for current from the line to the load. A 5-jaw socket is similar to a 4-jaw socket, but also has a neutral connection for the meter. The 5th jaw can be factory or field installed. Landis+Gyr offers a special 5-jaw socket for 3-phase, 3-wire applications with the 5th terminal in the 6 o'clock position. An insulating block secures the lugs, jaws, and bussing to the enclosure. A service entrance is the place where electrical service conductors enter a building. Service conductors can enter from overhead, entering the socket at the top, or from underground, entering the socket at the bottom. Sockets designed for underground service are usually wider in order to provide space for the conductors to loop around the block to the top connectors. Combination overhead underground sockets are designed for use with either service. A cover plate for openings at the top of the socket is required in underground feed applications. Some meter sockets have a side wire design with an offset socket to provide more wire bending space for easier underground wiring. When in operation, electrical current flows from the service, the line side, conductors, through the meter to the load side conductors, and then to the load center or panel board for distribution to branch loads. Because a self-contained meter completes the circuit between the utility and the customer, in order to change the meter, the circuit must be broken. This is often not acceptable in some applications and can be a safety hazard to utility personnel. Therefore, some meter sockets have a bypass that, when engaged, provides a path for unmetered current flow when the meter is pulled out. Common types of bypasses include lever bypasses, horn bypasses, test block bypasses, and plunger bypasses. The type of bypass used depends on electric utility requirements. Landis+Gyr invented the lever bypass socket. The basic design of this bypass has not changed since its original inception, making this a solid, time-proven design. A lever bypass has a manually operated lever that controls a bypass link that runs between the meter socket jaws. With a clamping jaw lever bypass, the lever applies pressure to the jaws, which grasp the terminals of the meter. With a non-clamping lever bypass, the lever has no effect on the pressure the jaws put on the meter. Utilities generally prefer the clamping jaw lever bypass because the meter cannot be pulled or installed unless the bypass is engaged. When the bypass is not engaged, the meter is locked into position by the jar assemblies. A clamping jaw lever bypass has a nylon cylinder with a copper strap running through it. When the lever is moved to engage the bypass, it moves the copper strap into contact with the upper and lower jaws. The strap also forces the jaws open, releasing the meter. Horn bypasses, which are factory installed option on residential sockets, are metal tangs attached to each lug in the socket. The tangs provide connection points for utility personnel to attach insulated jumper leads. A single-phase socket requires 2 jumpers, and a 3-phase socket requires 3 jumpers. When the jumpers are attached, they provide a path for current to flow directly from the socket's line side connections to its load side connections. The meter can then be pulled from the socket without disconnecting the load from the power source. With a test block bypass (TBB) socket, the line and load connectors are mounted parallel to one another. This provides a provision to bypass the meter by placing jumpers to connect the line and load buses. This type of bypass is used primarily by utilities subscribing to USERC metering standards. USERC is the Electric Utility Service Requirements Committee. Utilities that are USERC requirements are mainly located in the western United States. A plunger bypass has a spring-loaded bridging contact contained with each housing. This contact is driven away from the spaced end portions of the associated contact brackets by a plunger that's engaged when a watt-hour meter is installed. When the meter is removed from the socket, the plunger bypass contacts automatically close, providing a path for current to flow from the line to the load. The plunger bypass is only used in CT sockets. There are two types of meter covers, ring and ringless. A ring-type meter has a cover that must be installed before the meter can be installed. This means that the cover does not have to be removed to remove the meter. A metal sealing ring secures the cover and meter to the socket. A power company seal is attached to the sealing ring to prevent tampering. There are two types of sealing rings. One type has a snap to secure it in place. The other type is secured with a screw-type mechanism. Both types of rings are made of stainless steel or aluminum. A ringless type meter socket requires the meter to be installed before the cover is closed. After the cover is closed, a latch and hasp mechanism holds the cover in place. A power company seal is attached to the mechanism to prevent tampering. Single position meter sockets have an AC voltage rating of 300 or 600 volts per UL specification 414. UL 414 also identifies two operational current ratings for a single position meter sockets, a continuous current rating and a maximum current rating. Both ratings are in amperes, or amps for short. As the name implies, the continuous current rating is the amount of current that the meter socket can handle continuously without damage. The maximum current rating is the maximum current the socket can handle without damage for a short time. UL 414 allows the maximum current rating for a meter socket designed for a single-phase 3-wire service to be no greater than 125% of the continuous current rating. Because gang sockets have busing that must carry the current for all the sockets in the assembly, UL 414 requires that they also have an overall assembly continuous current rating in amperes. This overall rating is also referred to as the line bus rating. We just finished section 1, so let's start in with our first knowledge check. Question 1. Blank meters use current transformers to tap off a portion of the current for measurement. Is it A, self-contained, B, transformer rated, or C, all? Question 2. A blank neutral has 4 connection points for neutral and ground conductors. Is it A, double, B, duplex, or C, triplex? A blank socket is designed for single-phase applications with a neutral connection for the meter. Is it A, 4-jaw, B, 5-jaw, C, 6-jaw, or D, 7-jaw? Question 4. A/N blank is used to keep the electrical service connected to the load when the meter is removed. Is it A, base, B, bypass, C, cover, or D, enclosure? Question 5. Blank meters can be removed from a socket without removing the meter socket cover. Is it A, ring type, B, ringless type, or C, all? We'll now move on to section 2, and this part of the basics of meter mounting equipment covers Siemens meter sockets, some of which carry the Landis+Gyr trademark. Landis+Gyr offers both ringless and ring-style residential meter sockets. The enclosures are made of steel or aluminum and accept type RX hubs, that's 0.75 inches to 2.5 inches. Continuous current ratings range from 135 to 200 amps. Residential sockets are available for overhead feed only, underground feed only, overhead or underground feed with sidewire design. 4-jaw and 5-jaw sockets are available. A 5th jaw can be installed in the field in the 3 or 9 o'clock position. A horn bypass is also available as a factory installed option. 2-watt oversized lay-in lugs on 135 amp sockets make wiring easier. Oversized 350 kc mil lay-in lugs are available for 200 amp devices. UAT1, UAT3, and UAT4 socket designs are made of modular blocks, meaning there are only 5 parts to every residential device. UAT1, 3, and 4 designs have a quad neutral as standard. USA 8 offset or sidewire sockets, however, have more than 5 parts and do not have the quad neutral. HQ commercial sockets have a clamping jaw lever bypass design that has been the quality standard for meter mounting equipment for over half a century. HQ sockets are available in the following configurations: overhead feed only, underground feed only, overhead or underground feed, and the sidewire design shown in the accompanying illustration. These sockets have a maximum voltage rating of 600 volts and are available with 200 or 320 amp continuous current ratings. However, 200 amp rated sockets are built to the same specifications as 320 amp rated sockets. 200 amp rated sockets can either have lay-in lugs or studs. 320 amp rated sockets generally have studs, but some sockets offer lay-in lugs pre-installed at the factory. Studs can be either 3/8 or 1/2 inch in diameter. Siemens lugs have either a 13/32 inch opening to fit 3/8 studs or 9/16 opening to fit 1/2 inch studs. It's important to make sure that the lugs ordered fit over the stud sizes in the meter socket. 200 amp sockets accept Type RX hubs, which fit 3/4 to 2.5 inch hub sizes. 320 amp sockets accept Type HD hubs, which fit 3 inch to 4 inch hubs. HD and RX hubs are all interchangeable with Milbank hubs. A hub adapter plate, part number H9747-1113, is available to adapt an HD hub to an RX opening. HQ sockets are available with 4, 5, or 7 jaws. For 200 amp rated sockets, a 5th jaw can be installed at a 9 o'clock position in the field, but requires the user to run a wire to ground the jaw. The 5th terminal kit part number is H35815-2. CQ commercial sockets have a non-clamping lever bypass design and are available in the following configurations: overhead feed only, underground feed only, or overhead or underground feed. These sockets have a maximum voltage rating of 600 volts, a continuous current rating of 200 amps, and a maximum current rating of 250 amps. Bypasses are 50% rated, which means that they can safely handle the same current as the meter socket. CQ sockets are available with 4, 5, or 7 jaws and include lay-in lugs. They accept RX hubs, which fit 3/4 inch to 2.5 inch hub sizes and are interchangeable with Milbank hubs. The CQ socket should not be interchanged with HQ lever bypass sockets. Utilities usually require one or the other. Multi-position sockets, also called gang sockets, group multiple sockets in a pole section in the same enclosure. In general, gang sockets have the same features as single-position sockets. Available configurations include 2-position through 6-position gang sockets in a horizontal design and 2-position or 3-position gang sockets in a vertical design. A gang socket can come with no bypass, a horn bypass, or a lever bypass on each socket. The accompanying illustration shows examples of 3 configurations: a 2-position gang socket with center pole section, a 3-position end-fed gang socket, and a 3-position gang socket with 1 socket to the left of the pole section and 2 sockets to the right. Each position has a continuous current rating from 135 to 320 amps depending on the model. The maximum current rating is 400 amps per position for lever bypass sockets and 250 amps per position for the horn bypass sockets. Gang sockets with 100 amp continuous current ratings per position are also available and come in both center or end feed versions. Center feed models are designed so that the wires can come in from the hub opening over the pole section or from a center knockout below the pole section. An end feed unit has hub openings for wires on both the right and left ends. For larger applications where it's necessary to meter loads which have a continuous current above 320 amps and/or when the applied voltage is 3-phase, 480-volt, transformer-rated watt-hour meters are often used. These meters are also used in off-peak metering applications where the utility controls the power applied to a device to limit energy consumption during peak demand periods. PTS transformer-rated meter sockets come with 6, 8, or 13 terminals and are constructed of 16-gauge galvanized steel with polyester powder coat finish. 12-gauge aluminum is available as an option. Both solid and split covers are also available. The block assembly is glass fiber reinforced polyester, which is strong and arc and track resistant. PTS sockets have a 600 volt maximum voltage rating and a 20 amp continuous current rating. They come equipped with screw type terminals and pressure plate and spacing for multiple test switch configurations. A ground lug is available for all units, and a plunger bypass is available on 8 terminal or 13 terminal sockets. Transformer-rated watt-hour meters use current transformers, CTs, mounted internal or external to the meter. A CT is a precision-wound coil of wire through which a conductor is passed. Each service conductor passes through its own CT, and when power is applied, current from a service conductor induces a proportional current in its CT. Current from each CT is supplied to the transformer-rated meter that measures and displays the energy used. CTs are often housed in an enclosure called a CT cabinet located at the service entrance. However, off-peak CT metering systems often do not use a CT cabinet. One safety issue associated with CTs is that they must remain connected to the load when current is applied. Otherwise, the voltage induced across the CT will rise to a dangerous level. Instrument-rated meter sockets with test switches provide an excellent method of shorting CT circuits as well as disconnecting voltage sources to the potential coils in the meter. By utilizing these test switches, meters may be changed safely and efficiently. Test switches also provide an opportunity to energize individual stators in the meter. This is important when verifying that an instrument-rated metering installation has been wired correctly. Color-coded test switch handles may be ordered to match the utility's wiring color code. This enhancement simplifies wiring of the meter socket. HQT and HQTS transformer-rated meter sockets are constructed of 16-gauge galvanized steel with polyester powder coat finish. 12-gauge aluminum is available as an option. The block assembly is glass fiber reinforced polyester, which is strong and arc and track resistant. HQT and HQTS meter sockets have a 600-volt maximum voltage rating and an 80 amp continuous current rating. They come equipped with screw-type terminals and a pressure plate. Some sockets come with spacing for multiple test switch of configurations. A ground lug is available. All sockets are equipped with a 200% rated clamping jaw lever bypass. A removable bypass handle is available as an option. With the handle removed, a solid cover can be placed on the box with the bypass closed when it's necessary to remove the meter for in-shop repair or testing. Type K4, K5, and K7 meter sockets offer extended range metering, which is the direct metering of loads above 320 amps without separate current transformers. K-base sockets are available with steel or aluminum enclosures and an overhead service, underground service, and offset socket side wire designs. All K-base sockets use Landis+Gyr bolt-in self-contained meters. For single-phase residential and commercial applications, K4 and K5 meter sockets are available for 400 amp continuous duty or 480 amp continuous duty with a 600 amps maximum. For three-phase applications, Type K7 sockets provide 480 amps continuous duty, 600 amps max. Lugs are available in 1, 2, and 3 conductor configurations for K4 and K7 sockets. A bypass is generally not included with K-base sockets, but can be ordered separately and installed in the field. K-base bypasses are clamped onto the studs before the meter is removed. Two types of bypasses are available for K-base sockets: rake type and rotating link type. The rotating link type bypass is the only bypass that can be used with the K7 sockets. The rake type bypass clamps from the line to the load bus and is capable of carrying 480 amperes continuously. The insulated handles on the bypasses prevent the enclosure cover from being installed with the bypass in place. The out-of-service storage position for the watt-hour meter allows utilities to store the meter in the socket when it's taken out of service. A sliding plate with the words "out of service" printed on it identifies the meter status. A plastic blank meter hole cover should also be used when the meter is out of service. That concludes Section 2. Let's move on to the next knowledge check. Question 1. Landis+Gyr and Siemens residential meter sockets have continuous current ratings from 135 to blank amps. Is it A150, B175, C200, or D225? Question 2. HQ commercial meter sockets are available with continuous current ratings up to blank amps. Is it A220, B270, C300, or D320? Question 3. Blank group multiple sockets and a pull section in one enclosure. Is it A, CQ sockets, B, HQ sockets, C, gang sockets, or D, side wire sockets? Question 4. Blank meter sockets are transformer rated and have a 20 amp continuous current rating. Is it A, HQT, B, HQTS, C, K-base, or D, PTS? Question 5. Blank meter sockets provide for direct metering of loads above 320 amps without separate current transformers. Is it A, HQT, B. HQTS, C. KBase, or D. PTS. Section 3 of the Basics of Meter Mounting Equipment covers Siemens meter combos. Siemens meter combos include two product families, meter mains and meter load center combinations. Each family is further divided into USERC approved and non-USERC products. All products are UL listed as suitable for use as service entrance equipment and have padlocking provisions. Continuous current ratings for all four categories of Siemens meter combos range from 100 to 400 amps, except for non-USERC meter load center combinations, which range from 125 to 400 amps. Equipment Utility Service Requirements Committee, USERC, is an organization of approximately 80 utilities in 12 western states. One of the functions of USERC is to specify manufacturing and installation requirements for metering and service equipment. Utility companies dictate when USERC conforming equipment must be used, but USERC equipment can also be used in areas where it's not required by the utility. A meter main is a meter socket combined with a main circuit breaker in one enclosure. This arrangement is sometimes required by utilities because it places the main breaker external to the residence, making it easier for service personnel to disconnect power. All of the specified information needed to select a meter socket is also needed when selecting a meter main. This includes the amp rating, enclosure type, bypass type, service conductor feed, either underground or overhead, and number of jaws. In addition, the frame type, continuous current rating, and interrupting rating the circuit breakers is also needed. The National Electric Code requires that the electrical service to a building must have a disconnecting means consisting of no more than 6 devices, switches, or circuit breakers. This means that a load center with more than 6 branch circuits must have a main circuit breaker unless a main circuit breaker is provided separately. Where a meter main is used, a breaker in the meter main provides the disconnecting means for a downstream main lug only load center, and a load center is not limited to only 6 branch circuit breakers. For example, meter main MM0404L 1400 RLM is shown in the accompanying illustration. This meter main allows for up to 2 circuit breakers. Each breaker can function as the main circuit breaker for downstream equipment. This means that if both circuit breakers are installed, 2 main lug only load centers could be located downstream and could contain more than 6 branch circuit breakers and still comply with the 6 disconnect rule. Siemens non-USERC meter mains are designed for single-phase 3-wire 12240 volt service and have 100 to 400 amp continuous current ratings and a 22,000 amp interrupting rating. Most feature a side-by-side design. However, a 100 amp over-under meter main, a meter socket on top, with a 10,000 amp interrupting rating is also available. Some Siemens meter mains contain a limited number of extra spaces to provide easy wiring of outdoor circuits such as air conditioning units and spas. Options include factory installed or field installed main breakers, 2 or 6 circuits, ringless or ring type meter socket, and overhead or overhead underground service entry. Siemens non-USERC meter mains are available in the 2 configurations shown in the accompanying illustration. Siemens USERC meter mains have the same features as other Siemens meter mains and are available in the 2 configurations shown in the accompanying illustration. Side-by-side construction meter mains have 100 to 200 amp continuous current ratings and a 22,000 amp interrupting rating. Side-by-side 400 amp construction meter mains have a 320 amp continuous current rating, 400 amps max current, and a 22,000 amp interrupting rating. A meter load center combination is a meter socket combined with a main breaker and load center. However, when only 6 or fewer branch circuits are needed, the National Electric Code does not require a main breaker. Meter load center combinations are gaining in popularity because having the meter socket, main breaker, and load center in one location allows contractors to save on labor and material. Most Siemens meter load center combinations include a main circuit breaker, which serves as both the main service disconnect device and the main circuit protection device. Some meter load center combinations, however, do not include a main breaker and are referred to as main lug only, or more simply, main lug meter load center combinations. Main lug meter combos must still comply with the 6 disconnect rule. Some Siemens meter load center combinations are designed for overhead service entrance. Others are designed for underground service entrance. Most, however, are designed for either overhead or underground service and include a wire trough for use with underground service conductor. Some Siemens meter load center combos are designed for surface mounting, and others are designed for flush mounting. Units designed for surface mounting can be adapted to flush mounting with the use of a flush rail kit. Some Siemens meter load center combinations have feed-through lugs on the opposite end of the load center bus from the main breaker. This allows cables to be connected to a downstream main lug-only load center, provided that the meter load center current ratings are not exceeded. Each meter load center combination has a circuit capacity. For Siemens meter load center combinations, the most common circuit capacity is 8 1-inch spaces and 16 possible circuits. For example, the MC0816B 115CT meter load center combination shown on the left in the accompanying illustration provides a main circuit breaker and space for additional outdoor circuits, such as for an air conditioner or well pump. The unit's feed-through lugs can be used to supply power to a downstream main lug-only load center, which protects circuits inside the house. When a meter load center combination is used without another panel to power the entire home, more circuits are needed than an 0816 configuration can provide. For such applications, Siemens offers large capacity meter load center combinations, such as the MC4040B1200 SECW combo shown on the right in the accompanying illustration. This meter combo has a socket area on the left and a full-size load center interior on the right with 40 1-inch spaces for 40 circuits. Siemens non-USERC meter load centers are designed for single-phase, 3-wire, 120-240 volt service and have a 125 to 400 amp continuous current ratings and a 22,000 amp interrupting rating. All non-USERC meter load centers are designed for surface mounting. Siemens non-USERC meter load centers are available in configurations shown in the accompanying illustrations. Over-under combination service meter load centers have a meter socket on top and a load center on bottom. They can accept an overhead service or can be fed from underground through a removable gutter trough. They're available with 150 or 200 amp continuous current ratings. Load center circuit capacities range from 8 to 40 circuits. Side-by-side meter load centers can be fed from overhead or underground. They're available with 125 to 400 amp continuous current ratings. The load center circuit capacities range from 8 to 40 circuits. 350 and 400 amp side-by-side meter load centers are sometimes also referred to as house panels. However, these devices are not only used for single-family home applications, but also for apartments, condos, clubhouses, and other applications. Over-under overhead service meter load centers have a meter socket on top and a load center on the bottom. They're available with 150 or 200 amp continuous current ratings. The load center has 8 circuits. These meter load centers are sometimes referred to as trailer panels because they can be easily mounted to a telephone pole near a trailer. Siemens USERC meter load centers are available in configurations shown in the accompanying illustration. Side by side, between the studs meter load centers have rails to adjust semi-flush mounting depths, but surface mounted products are also available. These meter load centers have a meter socket on the left and a half load center on the right. They can be fed from overhead or underground. They're available with 100 to 225 amp continuous current ratings. Load center circuit capacities range from 6 to 48 circuits. Over-under between the studs meter load centers have the load center on top and are underground fed only. Both semi-flush and surface-mounted versions are available. They're available with 200 or 225 amp continuous current ratings. Load center circuit capacities range from 12 to 42 circuits. Side-by-side, full load center products must be surface-mounted, but offer the greatest amount of wiring space. These meter load centers can be fed from overhead or underground. They have a 200 amp continuous current rating. The load center has a 40 circuit capacity. Side-by-side, 400 amp construction meter load centers have a meter socket on the left and full load center on the right. Both underground and underground overhead feed products are available. Surface and flush mount versions are available. All versions have a 320 amp continuous current rating with a 400 amp maximum current. Load center circuit capacities range from 2, main breaker only, to 42 circuits. Reviewing the meter combo part numbering system is useful to understand how to correctly select and order a specific item. As shown in the accompanying example, MC3040B1200 SECW is the correct part number for a meter combo with the following characteristics: meter load center combination, 31-inch spaces, 40 circuits, its main breaker, its single phase, 200 amp continuous current rating, it's surface mounted, U-circuit approved, overhead or underground feed, and has a wide load center design. Section 3 is complete. Time for another knowledge check. Question 1. A/and blank is a meter socket and main breaker in the same enclosure. Is it A, AC disconnect, B, enclosed circuit breaker, C, meter main, or D, meter load center? Question 2. Siemens meter mains and meter load center combinations are available in both U-circ and non-U-circ configurations. Is it A, true, or B, false? Siemens non-U-circ meter mains are available in which of these configurations? Is it A, side-by-side, or B, over-under for overhead service, or C, both of the above? Question 4. Siemens non-U-circ meter load center combinations are available in which of these configurations? Is it A, side-by-side, B, over-under for combination service, C, over-under for overhead service, or D, all of the above? Question 5. Siemens meter load center combination part numbers begin with a blank. Is it A, LC, B, MC, C, ML, or D, MM? Let's begin Section 4. This part of the basics of meter mounting equipment covers Siemens multifamily metering. Overcurrent protection devices, such as circuit breakers and fusible switches, are rated according to the maximum voltage they can handle. The voltage rating of the overcurrent protection device must be at least equal to the circuit voltage. The voltage rating can be higher than the circuit voltage, but never lower. Some circuit breakers have what is referred to as a slash voltage rating, such as 120/240 volts. In such cases, the breaker may be applied in a circuit where the nominal voltage between any conductor and ground does not exceed the lower rating, and the nominal voltage between the conductors does not exceed the higher rating. Every circuit breaker or fusible switch also has a continuous current rating. For a circuit breaker, that's the maximum continuous current a circuit breaker is designed to carry without tripping. For a fusible switch, it's the maximum continuous current that the fuse is designed to carry without opening. The current rating is sometimes referred to as the ampere rating because the unit of measure is amperes, or amps. Conductors are also rated for how much current they can carry continuously without exceeding their temperature rating. This is commonly referred to as the conductor's ampacity. In general, the ampere rating of a circuit breaker or fusible switch and the ampacity of the associated conductors must be at least equal to the sum of any non-continuous load current plus 125% of the continuous load current. When selecting equipment with overcurrent protection devices, it's essential to know available fault current. Each overcurrent protection device is rated according to the maximum level of current it can interrupt. This is the device's interrupting rating, also referred to as its ampere interrupting rating. When designing an electrical power distribution system, a main circuit breaker or fusible switch must be selected that can interrupt the largest potential fault current that can occur in the selected application. The interrupting ratings for circuit protection devices downstream from the main device must also be taken into consideration. But these interrupting ratings will depend upon rating method applied. The National Electric Code provides for two methods to meet overall system interrupting requirements: the full rating method and the series rating method. The full rating method requires selection of circuit protection devices with individual ratings equal to or greater than the available fault current. For single-family homes, the available fault current normally does not exceed 10,000 amps. This makes it inexpensive to use the full rating method. For commercial applications, the available fault current often exceeds 10,000 amps. For example, when the full rating method is used in the case of a building with 22,000 amps of fault current available at the service entrance, every circuit breaker must have an interrupting rating of at least 22,000 amps as shown in the accompanying illustration. The series rating method also requires that the main upstream circuit protection device have an interrupting rating equal to or greater than the available fault current of the system. But subsequent downstream circuit protection devices connected in series can be rated at lower values. For example, a building with 22,000 amps of available fault current could have the breaker at the service entrance with an interrupting rating of 22,000 amps and additional downstream branch breakers rated at a lower level or value. In this example, the downstream branch circuit breakers have a 10,000 amp interrupting rating. The series rating method is less expensive to the customer because it allows use of branch circuit breakers with a lower interrupting rating. In larger installations, such as apartments, condominiums, and commercial facilities, the available fault current will normally be greater than 10,000 amps. In these situations, it's not uncommon to see 3 or more breaker series combinations. For example, the main power of an apartment complex example might have 65,000 amps available fault current. The main disconnect must be capable of interrupting this fault current. The tenant main breakers, however, may only have to be rated for 22,000 amps of fault current, and the branch circuit breakers in tenant load centers may only have to be rated for 10,000 amps of fault current. Series-rated circuit breaker combinations must be tested in series in order to be UL recognized. In addition, NEC Article 110.22 requires the series ratings to be marked on the service entrance equipment enclosure. In addition to the gang meter sockets discussed earlier, Siemens offers the following options for multifamily metering, also referred to as group metering: Unipack metering and PowerMod with Quick System. Unipack metering is a self-contained system with 2 to 6 meter compartments. Unipack metering operates on single-phase, 3-wire, 120/240 VAC power. A fifth jar accessory kit is available for use when power is supplied from a single-phase, 3-wire, 120/208Y source. The pole section accepts either underground or overhead service conductors. A Unipack configuration always consists of a utility pole section with main lugs or stud terminations, 2 to 6 125 amp meter sockets, up to 65,000 amp interrupting rating, or 200 amp meter sockets, up to 100,000 amp interrupting rating, tenant circuit breaker provisions, and a floating dead front. Both ring and ringless meter covers are available. Because this design limits the number of meter compartments to 6, a main switch or circuit breaker is not required to comply with the National Electric Code 6 disconnect rule. A unique feature of the standard Unipack configuration is the angled breaker design. The slight angle of the breaker reduces the enclosure size, which saves wall space and reduces weight. In addition, the angle also makes circuit breaker wiring easier. Lugs are included in standard Unipack metering and cannot be changed out to increase the wire size. Each unit has a wiring diagram on the inside cover that specifies the wire size and accessories available. Using alternate lugs and wire size from what is stated in the wiring diagram voids the Siemens warranty. 125 amp Unipack units accept QP circuit breakers, and 200 amp units accept QPP breakers. All Unipack metering comes with a floating dead front. The dead front mounts over the breaker section. The twist outs on the floating dead front serve as filler plates to prevent access to live components when installing a 100 amp circuit breaker instead of a 200 amp circuit breaker. Meter covers and breaker covers are replaceable and have part numbers to simplify ordering. Flush rail kits that allow Unipack metering to be semi-flush mounted are also available separately. A NEMA stud kit is available to allow Unipack metering to meet UCERC requirements. The stud kit can be installed for overhead or underground feed. Ringless Unipack metering with lever bypass is a variation of the standard Unipack metering design. This newer design is needed to comply with the lever bypass requirement of many utilities. As with the standard design, ringless Unipack metering with lever bypass configurations have 2 to 6 socket positions. However, all positions have a 200 amp continuous current rating, at 250 amps maximum, with a 100,000 amp interrupting rating. Positions are labeled for both Siemens and Murray circuit breakers. Bus current rating options are 400 or 600 amps. Ringless Unipack metering with lever bypass does not feature angled breakers. However, the ample space between meters allows sufficient wire bending space, so the units are just as easy to wire as a standard Unipack meter. The high-quality HQ lever bypass sockets come with a fifth jar installed in the 9 o'clock position. Neutrals are centrally located, and ground lugs are independent for each position. Multiple lug kits and hub kits are available. Handles are included on either side of the enclosure to help in lifting and mounting the unit. A mounting rail on the back of the unit simplifies installation. QP and QPP circuit breakers are used in ringless unipack metering with lever bypass, as specified on the wiring diagram, and series rating labels included on the inside cover of every unit. These labels also specify which hubs and lugs can be used. Lugs are not included in the pull section and must be purchased separately. Siemens PowerMod with Quick System modular metering includes an assortment of module types that can be configured to meet a wide range of residential and commercial group metering applications. For example, a typical application requires a main device module and one or more residential and/or commercial meter stacks. Depending on the application, additional modules such as a pull box, tap box, or spacer may also be required. PowerMod service can be single-phase 3-wire, 120/240 VAC 3-phase 4-wire, 120/208Y, or 3-phase 3-wire 240 VAC delta. The cross bus that connects all modules is aluminum and has a 1200 amp continuous current rating. PowerMod has a unique combination of 5 labor-saving features to aid the contractor during installation. Known collectively as Quick System, these features include Quick Connect, that's a single point for phase, neutral, and ground connections; Quick Torque, a breakaway nut design that makes it easy to achieve proper torque; Quick Bolt, spring-loaded captive bolts that provide a more accessible connection between enclosures; Quick Roll, rear mounting brackets factory installed with wheels for easy wall installation and lineup; and Quick Phase, field phaseable individual meter sockets that streamline ordering and phase balancing. Quick Connect is an exclusive Siemens feature that saves time by providing a single connection for phase, neutral, and ground, all tightened by a single nut that is externally accessible. The beveled edges on the Quick Connect allow for easy positioning of the joint. Quick Torque is an exclusive Siemens feature that saves time by eliminating the need for torque readings. When tightening, the outer head twists off at the proper torque for the connection. The remaining nut allows for release of torque if future maintenance or disassembly is required. Quick Bolt is an exclusive Siemens feature that simplifies installation of adjacent modules. With this feature, bolts are retracted until openings line up, at which time springs push the bolts through and maintain pressure while wing nuts are attached and tightened. Quick Roll is an exclusive Siemens feature that makes it easier to mount modules to a wall. Instead of metal scraping metal, Quick Roll allows the module to glide down the mounting rail via a durable nylon wheel inside a mounting bracket. Quick Phase provides maximum flexibility by allowing each individual meter position to be phased independently according to the user's needs. PowerMod has many features designed to speed installation and provide the contractor with maximum flexibility. For example, generous gutter space, removable knockout plate, movable ground and neutral provisions, and hinged rain channel simplify wiring. Each 225 amp meter socket in a residential meter stack, type WMM, has a provision for a 2-pole 225 amp plug-in QS circuit breaker. The compact QS breaker features a side-wire design that simplifies wiring by eliminating difficult wire bends. The QS breaker is available with continuous current rating from 100 to 225 amps and with interrupting ratings from 10,000 to 100,000 amps. If desired, a 2-pole 125 amp QP circuit breaker can be installed in a 225 amp Tennant main breaker slot without conversion kits or filler plates. Standard breaker modules type WB are designed for line and load side applications ranging from 200 to 2000 amps at 240 volts max. For 1200 amps and below modules, compression lug landing pads can be field installed and devices are rated for overhead and underground feed. 1600 to 2000 amp modules feature dedicated feed to minimize width and come with factory installed studs to which mechanical or compression lugs can be installed. A wide variety of lug options for aluminum and copper wire are available to help minimize cost and customize the module to your specifications. USERT compliant breaker pull box combination modules type WEB are designed for 240 volt max, line side, bottom feed applications up to 1200 amps for those areas that subscribe to the USERC standard, require compression lugs, or require separate compartments for the breaker and line side terminals. NEMA 2 stud pattern bolts are standard on every unit, enabling compression or mechanical lug use. Each module features a removable ground trough to facilitate pulling the grounding conductor through the pull section. Multiple ground lugs are included with every device. Standard switch modules type WS are designed for the line side and load side applications ranging from 400 to 1200 amps at 240 volt max. For modules at 800 amps and below, NEMA 2 stud pattern bolts are factory installed, enabling a wide variety of compression and mechanical lug options. 400 to 800 amp modules have the exclusive invertibility feature, allowing the user to simply rotate the enclosure to accommodate top or bottom feed. A wide variety of lug options for aluminum and copper wire are available to help minimize costs and customize the module to your specification. Class T fuse provisions are standard. USERC compliant switch pull box combination modules type WES are designed for 240 volt max, line side, bottom feed applications up to 1200 amps for those areas that subscribe to the USERC standard or require compression lugs. NEMA 2 stud pattern bolts are standard on every unit, enabling compression or mechanical lug use. Each module features a removable ground trough to facilitate pulling the grounding conductor through the pull section. Multiple ground lugs are included with every device. Class T fuse provisions are standard. Standard tap box modules type WTB are designed for line side, main lug, or load side or remote feed applications ranging from 400 to 600 amps at 240 volt. NEMA 2 stud pattern bolts are factory installed, enabling a wide variety of compression and mechanical lug options. All modules in this family feature the exclusive invertibility feature, allowing the user to simply rotate the enclosure to accommodate top or bottom feed. USERC compliant tap box pull box combination modules type WET are designed to 240 volt max, line side, bottom feed applications up to 1200 amps for those areas that subscribe to the USERC standard, require compression lugs, or require more wiring bedding space than the standard tap box. NEMA 2 stud pattern bolts are standard on every unit, enabling compression or mechanical lug use. Residential meter stacks type WMM are available in 125 and 225 amp per position modules. 2 through 6 position, 125 and 225 amp stacks are available in ring and ringless, with or without horn bypasses versions. Modules with 3-phase through bus have the quick phase feature. 225 amp modules use the new QS type breaker, which eliminates multiple bends in tenant service conductors and allows 125 amp conversion without the need for costly labor-intensive conversion kits. Commercial meter stacks with lever bypasses type WML are available with 240 volt max, single phase and 3-phase tenant main provisions. 100 amp 3-phase tenant main stacks are available up to 4 positions. 225 amp single phase and 3-phase tenant main stacks are available up to 4 positions. 320 amp 3-phase tenant main stacks are available up to 2 positions. WML stacks use the Landis & Gyr type HQ lever bypass. Stacks with single phase 225 amp provisions can be converted to 125 amps without the need for costly labor-intensive conversion kits. USERC compliant commercial meter stacks with test block bypasses type WMT are available with single phase and 3-phase tenant main provisions. 225 amp single phase and 3-phase tenant main stacks are available up to 3 positions. Stacks with single phase 225 amp provisions can be converted to 125 amps without the need for costly labor-intensive conversion kits. K-Base is a bolt-in meter socket design and provided exclusively by Landis & Gyr. Utility acceptance varies, so check for approval prior to selection. Commercial meter stacks with K-Base meter sockets, type WMK, are available with 240 volt max, single phase, 3-phase tenant main provisions. 3-phase in, single phase out stacks use the K5 meter socket. 3-phase in, out stacks use the K7 meter socket. Both types of sockets are available in 1 position, 400 and 600 amp configurations. K7 modules are also available with 2 positions at 400 amps per position. The accompanying illustration shows a few configuration examples. Other configurations are also possible. For simplicity, only 1 or 2 meter stacks are shown for each configuration, but additional meter stacks can be added as long as the cross-bus and main device specifications are not exceeded. Utilities have varying requirements for equipment height, cover types, and bypass types. Therefore, utility acceptance should be obtained prior to installation of any modules. A tap box provides a direct connection to the cross-bus and does not provide any overcurrent protection. A tap box should never be used to feed a main device module types WS, WB, WES, or WEB, as this would bypass the overcurrent protection. Configuration 1 uses a tap box and does not have a main breaker or main fusible switch, which is permissible as long as there are 6 or fewer disconnects. Configuration 2 has a main breaker and main fusible switch, so this configuration permits more than 6 disconnects downstream from the main disconnect. Configuration 3 uses a tap stack to connect the configuration to a busway run. Configuration 4 uses a spacer. A spacer is commonly required between a meter stack and the main disconnect module, or tap box, for USERC installation. A spacer can also be used to extend the length of the lineup when needed. Configuration 5, unlike the other configurations, is center-fed. For center-fed applications, the total current in the main device may exceed 1200 amps if the main device is rated accordingly, but the cross-bus current on either side of the main device cannot exceed 1200 amps. Following the configuration rules described in PowerMod documentation is critical to ensure proper operation. The accompanying illustration shows 2 examples of improper configurations. Configuration 1 is improper because it uses a tap box with the main device. Because the tap box connects directly to the cross bus, the main device is bypassed. Configuration 2 is improper because it does not have a main device and has more than 6 disconnects, violating the NEC 6 disconnect rule. Well, that concludes section 4. Now let's go on to our last knowledge check. Question number 1. Because its design limits the number of meter compartments to 6, a Unipack metering configuration does not require a main switch or circuit breaker to comply with the NEC 6 disconnect rule. Is that A, true, or B, false? Question 2. Which of the following PowerMod Quick System features is a single point for phase, neutral, and ground connections? Is it A, quick connect, B, quick bolt, C, quick torque, D, quick roll, or E, quick phase? Question 3. PowerMod cross buses are aluminum with a continuous current rating of blank amps. Is it A, 1000, B, 1125, C, 1200, or D, 1500? Question 4. Type blank PowerMod residential stack modules are available with 2 to 6 positions at 125 or 225 amps per position modules. Is it A, WMK, B, WML, C, WMM, or D, WMT? To the final exam. Question 1. Which of the following items are connections that accept the blades of the utility meter and establish secure electrical connections between the meter and meter socket? Is it A, lugs, B, studs, C, insulating blocks, or D, jaws? A/An blank secures the lugs, jaws, and busing to a meter socket enclosure. Is it A, neutral, B, stud, C, insulation block, or D, bypass? A blank meter socket design provides more wire bending space for an underground service. Is it A, side wire, B, 5 jaw, C, combination? Question 4. Which type of meter socket bypass can have either non-clamping jaws or clamping jaws? Is it A, lever bypass, B, horn bypass, C, test block bypass, or D, plunger bypass? Question 5. A/An blank meter socket cover requires the meter to be installed before the cover is closed. Is that A, ring type, B, ringless, C, NEMA 1, or D, outdoor? Question 6. UAT 1, 3, and 4 meter socket designs have a blank neutral. Is it A, single, B, duplex, C, triplex, or D, quad? Question 7. Which of the following meter socket types is a commercial meter socket with a non-clamping lever bypass? Is it A, UAT, B, AS8, C, HQ, or D, CQ? Question 8. Which of the following meter socket types is a commercial meter socket with a clamping jaw lever bypass? Is it A, UAT, B, AS8, C, HQ, or D, CQ? Question 9. Siemens vertical gang sockets have a maximum of blank meter sockets. Is it A2, B3, C4, or D6? Question 10. Which of the following types of meter sockets is a transformer rated socket with a continuous current rating of 20 amps? Is it A, PTS, B, HQ, C, HQT, or D, HQTS? Question 11. Which of the following types of meter sockets offer extended range metering? Is it A, PTS, B, K-base, C, HQT, or D, HQTS? Question 12. Blank is an organization of utilities in 12 western states that specifies manufacturing and installation requirements for metering and service entrance equipment. Is it A, USERC, B, UL, C, NFPA, or D, NEMA? Question 13. Siemens non-USERC meter load centers with an over-under overhead service configuration are also referred to as blank. Is it A, trailer panels, B, house panels, C, meter mains, or D, temporary service panels? Question 14. The blank rating method allows downstream circuit protection devices to have a lower interrupting rating than the main circuit protection device. Is it A, partial, B, full, C, series, or D, parallel? Question 15. Unipack metering is a self-contained system with two blank meter compartments. Is it A3, B4, C5, or D6? Question 16. Unipack metering with blank bypass is a variation of the standard Unipack metering design. Is it A, horn, B, lever, C, rake, or D, test block? Question 17. Which of the following power mod with quick system features is a single point for phase, neutral, and ground connections? Is it A, quick connect, B, quick bolt, C, quick roll, or D, quick torque? Question 18. Power mod cross buses are aluminum with a continuous current rating of blank amps. Is it A, 1000, B, 1125, C, 1200, or D, 1500? Question 19. Type blank power mod residential stack modules are available with 2 to 6 positions as 125 or 225 amps per position modules. Is it A, WMK, B, WML, C, WMM, or D, WMT? Question 20. Which of the following power mod modules is a USERC compliant commercial meter stack? Is it A, WB, is it B, WES, C, WMM, or D, WMT? That concludes the Siemens Quick Step Basics of Meter Mounting Equipment. Thanks again for your time and attention.